Okay. First, let me start correcting a mistake I made yesterday. While we are finding the unit of the drag coefficient gamma, so we have to use this formula, right? F is equal to velocity times gamma. F has unit kilogram meter per second squared. V is m over seconds. So gamma from this is just kilogram over seconds. Last time I didn't write this properly, so I got confused. Okay. So last time we studied several things, and the last one was linear equations, right? So once we are given a linear equation like this, we okay, we find so-called an integrating factor, which is a function, so that when you multiply your equation through with this integrating factor, the right hand side of the equation becomes the derivative of mu times y. So you look for a function which does this, and then you write this down, you write this condition down, and from this you see that mu has to satisfy this differential equation. Mu prime should be equal to mu times p, and from this, writing it this way, we obtain this equation, and from this we see that mu has to be plus or minus exponential of the function p. Since we are just looking for one integrating factor, I can pick any of such mu's, and I pick the plus sign, and then we use that to solve the equation, and we see that the solution has this form. You don't have to memorize this at all. Each time we just find the integrating factor and then multiply the equation with that factor, and we write down the solution. And we did one example here. So this differential equation, which is a linear equation, because no two y terms are multiplied, right? The function p is just 1 over 2, and q is 1 over 2 times e to the power 3 t over 3. From this, the integrating factor is just e to the power t over 2 plus c. And since we just want one integrating factor, why not choose c to be 0, so that we get something simple, which is e to the power t over 2. And then we multiply our equation by this integrating factor, and we see that the left hand side, which is this expression here, becomes just the derivative of y times e to the power t over 2, and then we integrate both sides and solve the equation. Okay, so this is what we did last time. Let me just do one more example. Okay, from the book, let me see, exercise 14. All right, or 16. Okay, so let me do exercise 16 at page 40. So solve the equation. Actually, solve the initial value problem. It says initial value problem. I'll tell you what's an initial value problem, which is, okay, y prime plus 3 over t y equals cosine t over t cubed, and y at pi equals 0. And we would like to solve this for positive t. Okay, let me check again my if I copied correctly. Yes, okay, so that's the problem. Okay, now first we just try to find the solution of this equation. Let me rewrite the equation again. Please, stop me if you miss anything. Okay, if you don't understand anything, please stop me, or if I do something incorrect, please warn me. Okay, so we first identify what is P and Q. P is 3 over T, and Q, okay, cosine T divided by T cubed. Remember, we are given that T is positive, so that, there is no danger writing P and Q like this. Well, what is the integrating factor? Well, that was mu t, and it was e to the power integral of pt dt. So if I plug this, I get, okay, let me write here, e to the power 3 over t dt. Well, this is just e to the power uh, 3 times ln t plus c, right? And from this, we see that mu t is just e to the power c, some constant, times this is e to the power ln t cubed, e to the power ln t cubed. Exponential and logarithm cancels each other, so we get e to the power c times t cubed. Okay, and since I just want one integrating factor, we may just choose, just let c to be 0, so that mu t becomes just t cubed. Okay, so my integrating factor is just t cubed. Now I multiply my equation by the integrating factor, multiply the equation by t cubed, we will get what? T cubed times y prime plus t cubed times 3 over t y, and then t cubed times cosine t divided by t cubed. All right. Well, we see that the left-hand side is the derivative of the integrating factor times y. Let's check whether if this is really the case. Otherwise, it means that we have made a mistake earlier. Okay, so when you take the derivative, you get y prime times t cubed plus y times derivative of t cubed, which is 3t squared, and this is really 3t squared. And here t cubes are cancelled, so we have just cosine t, and then we do what? We just integrate both sides. Well, derivative of this is equal to cosine t, so this thing is just antiderivative of cosine t, right? So from this, we see that t cubed y equals antiderivative of cosine is just sine t plus a constant. This constant, of course, is different than the constant I used before. I used the same notation, but I hope there is no confusion. And from this we see what? Sine t over t cubed plus c over t cubed. And here what is c? C is of course any real number. So for any real number c, I have a solution. Okay. As I said earlier, once we see existence uniqueness theorem, we will see that this is the list of actually all solutions of the differential equation. What I was asked in the problem was slightly different than this. I was asked to solve the initial value problem. Okay. Initial value problem means what? Initial value problem means a differential equation and a condition, okay, on y. So in this case, it is just y pi at is equal to 0. So the value of the function y should be 0. This means what? This means actually, you see, just recall our direction fields. Okay. You see, this direction field gives us actually many solutions. Okay. All of these curves are solutions of this differential equation. When you are given an initial condition like the one we are given, it says what? Y pi is equal to some value. Okay. In that case, it is 0, but suppose it is not 0. Suppose something like this. This means what? You have to pick among those solutions the one which passes through this point. Okay. Y pi equals, let's say, 1. Okay. So I just pick this solution. So let's do that in our case. Okay. To solve the initial value problem, we need to use the initial condition. What was it? That was y of pi is equal to 0. So let's do that. Y of pi is equal to 0. So I have to plug pi here and should get 0. Let's see. 0 equals y pi. When I plug pi here, I get sine pi divided pi by pi squared plus c over pi squared, right? Sine pi is already 0, so this is just c over pi squared. And I want this to be 0. This is 0 only if c is 0. So this implies c is equal to 0. So hence the solution of the initial value problem IVP is what? Y equals c is 0. So it is just sine t over t cubed. Sine t over t cubed. Okay. So what happened? By just choosing a condition like this, we picked one of the infinitely many solutions of the differential equation. Okay. You see, actually, that such an initial value problem under some conditions has a unique solution like this one. Okay. Do you have any questions so far? Okay. If you don't have any, okay. Yani ben eğer y of p 0 değil de 3 olsaydı o zaman 0 olmayacaktı c değeri. Değil mi? Yani istersen yapalım. If the initial condition were y of pi equals, let's say, 1, then we would have ne olacaktı? 1 eşittir y of pi. So sin pi divided by pi cubed plus c over pi cubed, right? Sin pi is 0, so this is c over pi cubed equals 1. And from this we see that c would be just pi cubed, okay? Hence the solution would be, hence the solution of the initial value problem is ne olacaktı? Y eşittir sin x divided by pi cubed plus pi cubed over t cubed. Okay? Tamam mı? Sin t. Okay. Tamam mı? Şuradan bakalım isterseniz. Sin t divided by t cubed. Bu da. Özür dilerim. Bunu da yanlış yazmışım. Şöyle bir daha yazayım. Bu bilgisayar yazmanın böyle bir sıkıntısı var. Ekranın az bir kısmını görebildiğimiz için, hatta şöyle yazayım. Sin t plus pi cubed over t cubed. Right? Bakalım. Evet. C yerine pi cubed yazdık. So sin t plus pi cubed divided by t cubed. Tamam mı? Evet. Ha, fonksiyonun diğer değerlerini mi? Tabii. Fonksiyonu buldun artık. Fonksiyonu başka noktalarda hesaplayabilirsin. Onu soruyorsun. Tamam. Okay. Now let's see another type of equation, so-called separable equations. Actually, we have seen many examples of separable equations, but let's see more systematically. A first order equation, first we will study first order equation, then we will start second order equations. First order equations have usually the following form. If y is a function of, let's say, t or x, let's say x, then dy over dx is equal to fxy. So this is a general form of, this is the general form of first order equations. Why is that? Because since it is first order, you are allowed to have only y prime in the equation as a derivative term. So if you have one derivative term, y prime, you may collect y prime terms on one side and solve that equation algebraically in terms of x and y, so that you have y prime is equal to some expression in terms of x and y. So I write it this way. For example, linear equation we have studied above corresponds to what? If this fxy has the following form, let's say minus px y plus qx, kind of linear expression, right? In y, linear in y, okay. Then of course equation would be what? Then we have y prime is equal to minus px y plus qx, and this would give us y prime plus px y equals qx. Just the general form, just the general form of linear equations. Okay, maybe I should clarify one thing. Sometimes we use x as the independent variable, sometimes we use t as the independent variable. If the equation is linear, then we use mostly t as the independent variable. Otherwise, we use x. Okay. So if I write a general form of a first order equation, I will use x. But if in particular I consider a linear equation, I will mostly use t. All right. So what's a separable equation? If the function fxy has the form, let's say has the form fxy, let's say mx, okay, minus mx divided by nx, ny. Then the equation is called separable. Why separable? Because here you see your function is a product of two functions. One function is a function of x, the other one is a function of y. In other words, we can separate the variables x and y in product form, okay? A function of x times a function of y. If this is the case, we call the equation separable. Note that in this case, the equation becomes ne oluyor denklemimiz şu hale gelecek. Dy over dx fxy, so it is minus mx divided by ny, okay, and from this we have this, okay, I can write it either this way, y prime plus, no, y prime ny, or maybe write dy dx ny equals minus mx, or m dx plus, okay, ny dy. So we will see later that we write equations like this. We kind of separate dy and dx like this. This is just a notation, but it's a useful notation. However, keep in mind that when I write this, actually I mean this, okay? And how can we solve this? How can we solve this? You see, I have minus mx, or maybe let me write ny times dy dx, which is just okay minus mx. Well, this is a function of y only, and then I have here y prime, and here I have a function of x only. Let me write it this thing like this: y prime and then minus mx. You see, I can integrate both sides, and you see I have what here? I have n prime times y prime times dx. Well, if I have an antiderivative for the function ny and an antiderivative for the function mx, then I will be done. So let's say n tilde y and m tilde m m tilde x be antiderivatives for ny and mx. Okay, then this thing ny y prime is just what? This is just d of m no and y divided by dx. Why is that? Because you see, how would you take derivative of this gadget with respect to x? Well, you would first take derivative with respect to y and then dy dx, but n prime is an antiderivative for n, so this would be just ny and then y prime. Okay, so derivative of this expression is equal to this. Therefore, so integral of this expression, integral of this, which is ny times y prime, integral of that is just integral of this expression. So okay, şöyle yapayım. Integral of the right hand side is just minus m tilde x plus a constant, and then integral of this expression, which is this, is the integral of this expression. Okay, and this is nothing but this, of course, plus c2. So what we get is then ny plus m tilde x equals c2 or c1 minus c2. Okay, so this is of course just a constant, so we get the solution. And c is an arbitrary constant, because C1 is an arbitrary constant, C2 is an arbitrary constant, hence this is an arbitrary constant, and this is our solution. So what we see is that the solution is nothing but this expression where n tilde and m tilde are just antiderivatives for uh, uh, for m and n, right? Okay. If I pick antiderivatives for m and n, then the solution of the equation would be just this. Now let's see some examples. Okay. Okay. Problem 17. Okay. So solve the equation. Y prime equals 3x squared minus e to the power x divided by 2y minus 4. All right. Well, you see, uh, this is a separable equation because y prime is equal to fxy, and that is written as a product of a function of x times function of y. Okay, x and y variables are separated. And how do we solve this? Uh, so this is our m, and this will be our n, and so on. But actually, I don't have to go through all the steps. We can just do the following. You see, this is just dy dx, and I separate the variables doing this. So this is just 3x squared minus e to the power x times dx, and 2y minus 4 times dy. Okay, actually, I take this over here, so I get dy over dx. So I have a function of y times dy over dx, and then I just integrate both sides with respect to x, right? Actually, this is what I am doing. 2y minus 4 dy dx, and then we integrate both sides with respect to x. So 3x squared minus e to the power x times dx, and then 2y minus 4 dy dx dx. But you see, when you do that, actually what happens, you are just integrating this gadget with respect to y, right? Uh, you just take antiderivative of this, it means that you are just integrating this expression with respect to y. And in practice, that amounts to the following, as if we are just canceling this, and then we have dy here, and you integrate with respect to dy. This is exactly what's happening. Okay, so from this we get what? Here I have x cubed minus e to the power x plus is constant, and here you integrate with respect to y, so you get y squared minus 4y plus another constant, and from this we see that our equation is this. C, let's write just C. Here C1, C is just what? C1 minus C2. That doesn't matter. C is just an arbitrary constant, okay? Evet. Haklısın. 4y olacak. Evet. Kopyalarken yanlış yapmışım. Bir örnek daha yapalım. 23 demişim. Okay. Another example. This is problem 17 at page 48. Okay, page 48. This is problem 23. Again, okay, 23 at page 49. So the problem is this: solve the initial value problem. Initial value problem. Y prime is equal to 2y squared plus x times y squared, and y of 0 is equal to 1. Okay. You see, this is also separable because I can separate x and y variables like this, right? Y prime is equal to, yes, this. And from this, we get what? So dy, okay, this is dy over dx, 2 plus x divided by, no, y squared. And this is just, what? 2 plus x times dx is equal to dy over y squared, right? Right? And then we integrate both sides. So this is just 2x plus x squared plus 2 plus a constant, and this is just minus 1 over y plus another constant, and we see that this is just 1 over y plus 2x plus x squared over 2 is equal to c2 minus c1, which is just a constant. So this is the general solution. Actually, we don't know whether it is the general solution. General solution means that the list of all solutions. I am not sure at this moment whether this is the list of all solutions, but this is the list of solutions we could obtain so far. Among those solutions, I would like to pick up the one which takes the value 1 at 0. So let's do that. Okay, so y of 0 is equal to 1. So when I plug 0 for x, y should be 1. So we get 1 over 1 plus 2 times 0 plus 0 squared over 2 is equal to c. Well, from this we see that c equals 1. Therefore, the solution we obtained is this gadget. Actually, I can write it this way. So this is 1 minus x squared over 2 minus 2x, and this is just 2 minus x squared minus 4x over 2, right? Therefore, y would be just 2 over 2 minus 4x minus x squared. So I can just take my solution to the initial value problem as this function. All right. Let me do one more topic related to separable equations. So let's see another type of equations, so-called homogeneous equations. just recall that, once if we have a linear equation, we know how to solve it, right? uh, we could we derived a solution pattern for that. We find an integrating factor and so on. If you put linear equations on one side, there's a huge variety of nonlinear first order equations, and it turns out that you need to build a method for each type of those equations. For example, here we have seen separable equations, and we could solve separable equations somehow. Now I will show you another type of equation, and for this type of equations we will need another uh, method, and we will see later different kinds of equations, and we will see that each type of equation needs its special kinds of solutions. As I said yesterday, the world of nonlinear equations is very wild. Okay, we have tons of different types of equations, and almost all equations needs their theory to be developed. For some of them we have nice theories, but most of the time we don't have any theories actually. This so-called homogeneous equations is one of them, first order equations, and we have a nice theory for these. All right, so what we will consider is equations of this type. Y prime is equal to, let's say, ay plus b cy plus d. An equation of this type, of course this is a separable equation, because I can separate x and y variables. In this case there is no actually x variable, so only y variables. We can solve this. The way we solve this has a special technique. We will do the following. So to solve this equation, we make a variable change. What we do, uh, we let we replace the dependent variable, let's say y. In this case I consider y as a function of x, with uh, vx, which is just the original variable divided by x. Okay, and this gives us what? This gives us, so we have x times v, which is a function of x, is equal to y. And from this, taking derivatives with respect to x, we see what? Y prime is equal to derivative of x times v, right? And this is just derivative of x, which is 1 times v plus x times v prime. Okay, and we just take this and plug into the equation. You see this is y prime, so v plus x times v prime is equal to ay plus b and then cy plus d. And here what we do is the following. We divide everything by x, so we get a times y over x plus b over x, and then here we have this, and y over x is just v, so v plus, so with av plus b over x and cv plus d over x. And it turns out that usually this is a simpler equation. It doesn't look like in this case, but let's see this on some problems. Okay, let me see. For example, problem 30 at page, so example 30 at page uh, okay. All right, solve the equation. All right, dy over dx, y minus 4x, x minus y. Okay. Sanırım şurada şöyle şey yaparak yanlış yaptım. Burada da x olabilir. Evet. So we had x here. When you divide by x, okay, yeah, you get just b and d here. So yeah, and you see, once you have this, you have x times v prime, a v plus b, c v plus d minus v, and now equation is kind of separable because v prime is just this expression divided by x, so it becomes separable, so that it is separable now. Yeah, I am sorry, I started with the wrong expression. This is the correct expression to start with. In general, this is not neither linear nor separable, but once you make this substitution, it becomes separable. Okay. Yes. So when you divide by dy over dx. Okay, dx. Yes. Yes, you are right. Tamam. Tamamdır. Şimdi bir tane örnek yapalım. Ama bunu bir dahaki saat yapayım. Bakayım doğru mu kopyalamışım. Tamam. Okay, let's solve this in the second hour using the method I just described above. Okay.